Okay, for rotational symmetry, when you rotate something, you're turning it. So that's the key word we want to think about here. Okay, rotational symmetry, it says if the figure can be mapped onto itself by being rotated less than 360 degrees clockwise or counterclockwise about the center of the figure. So that's meaning I can make less than a full rotation. Okay, if I took this figure right here and I spun it around, so if I hold my pencil on this center point and I spin it like this looks exactly the same as what I started with. If I spin it a little bit more, that looks exactly the same, and if I spin it a little bit more, that looks exactly the same. So every time I turned my paper 90 degrees, or a quarter of a turn, I got the same figure. Okay, so we have rotational symmetry because I could rotate it every 90 degrees and it looks exactly the same. Maps it onto itself means that it looks exactly the same. Okay, the number of times that a figure maps onto itself as it rotates from 0 to 360 is called the order of symmetry. Okay, so since this figure has 90 degrees, every 90 degrees it looks the same. It has order 4, an angle rotation of 90. So we can take a full rotation of 360 and divide it by the order, and we get the angle. Or it also works the other way. If I take the 360, divide it by the degrees, and I could get the order. Either way works. Okay. It says a figure has point symmetry if it can be mapped onto itself by a rotation of 180. When you rotate something 180, it's basically flipping it upside down, right? So completely turn it around. That's 180 degrees. It looks exactly the same. So that's called point symmetry. Okay. The center of symmetry would be right here in the middle, and that would be our point of symmetry. Okay, let's look at some examples. So we're going to talk about this, and we're going to use a few more words than what it exactly says here. So let's look at our objects. We have a leaf here. Sometimes there's rotational symmetry, and it says determine which ones have rotational symmetry. So if I took this leaf and I turned it for leaf A, I am not getting a leaf that looks exactly the same, as I turn it, okay? I'm not getting the exact same thing. This has no rotational symmetry. Okay, no rotational symmetry. If it weren't for this little curved line here, if I just looked at, let's say, this part of the leaf, I could split it right down the middle and say it has line symmetry because it's symmetric. It looks exactly the same on the left and the right side if you ignore the stem. Okay, so you might be able to say line symmetry for that one. All right, this figure, this flower here, if I rotate it like this, it looks exactly the same. And then I rotate it like this, it looks exactly the same, and so on. And I could keep going, and I'm rotating it multiple times. I'm getting the same exact picture. So does this have rotational symmetry? Yes, it does have rotational symmetry. We could rotate it, let's see, 1, 2, 3, 4, 5, 6, 7. So there's 8 petals. So we could say it has an order of 8 because every time I turn to a new petal, it is going to look exactly the same. Okay. Now this question doesn't ask us to do that, but I'm just saying if it had asked us, that's what we would that's how we would answer it. Okay. If this question had asked us about line symmetry, we would also see line symmetry here because I could fold it down the center this way, I could fold it this way, I could fold it this way. So we're going to have multiple lines of symmetry in this one as well. So sometimes figures are both rotational symmetry and line symmetry. This is an example of that case. Okay. C, can I rotate this, which looks like a clover, a 4-leaf clover? Well, if I rotate it like this, it looks the same. Okay. And I could keep rotating it. If I rotate it here, it looks the same. If I rotate it here, it looks the same. So again, this one's like every 90 degrees, every quarter turn, it does have rotational symmetry. Okay, so this one, I'm turning from here to here, from here to here, and so on. This one, I'd have to make a quarter turn, go there to there, and so on. Okay, so there is rotational. Again, if it had asked me about line, I could split this right down the middle this way and get a line symmetry, or I could split it this way and get a line symmetry, or this way, or this way. So there is line symmetry in this one as well. So these would be both rotational and line. Okay, example 4, it says determine whether it has rotational symmetry and explain. Same directions. Can we turn this orange slice around and it look the same? So that's definitely a yes. These scissors, I cannot turn it around and it look exactly the same, right? It looks kind of similar, but this is bigger than this one, so they're not going to be exactly the same. So this is a no. And then this is a rectangular shape. Not exactly sure what it's supposed to be, some kind of screen. But if I turn this 180 degrees, if I turn it upside down, it looks the same. So this one is a yes. So one other thing that we talked about in the definitions, where we talked about point symmetry. And for point symmetry, it says if it's 180 degrees, we could say point symmetry. So in this figure, we would have point symmetry, and in this figure, because I could turn it exactly upside down and it looks the same. Same with these two up here, they would have point symmetry, because I could flip them upside down or turn them upside down 180 degrees and they would be the same. Okay, example 4 says determine if we have rotational symmetry. If so, locate the center of symmetry and state the order of symmetry and angle of rotation. So these symbols here are telling us that they're congruent, meaning they're the same size. And if all the sides are the same size, then all the angles are the same size too. You should have learned that in geometry. So if I were to turn this, it looks the same. And if I were to turn it again, it looks the same, and so on. I could turn this 5 times and it would look the same. So if I have 360 degrees and I divide it by 5, I get 72 degrees for my angle. Okay, so the angle of rotation is 72 degrees, the order is 5. For B, I cannot turn this and get the same exact shape. I can try, I can spin it around, but it's not going to look the same. So this is not going to be rotational. For C, I could turn it, it's not looking the same. It's not looking the same until I get completely upside down. Now it looks the same. So this one is yes. The order is going to be 2. So 360 divided by 2 is 180. Okay. All right, and then which one has point symmetry? Point symmetry would be figure C. And that's because it was 180 degree angle of rotation.